Hello everyone, welcome to another AP Computer Science video. Today we're going to do a couple practice problems with array lists to refresh and strengthen our understanding of the advantages and differences of array lists to the predecessor arrays. As we learn more about them, it might become more apparent that in most situations we would prefer an array list over an array. And the real big advantage that we saw last time was the fact that we can add or remove items and not have to worry about running out of space or not having enough space or placement of items or adjustment of items. It automatically is done for us, even though maybe behind the scenes there may be expensive operations. We don't have to worry about implementing them. They're going to do what we ask them. We're going to remove an item and everything will move over. We add an item and things will shift over. We add to the end of the list and they'll get stuck at the end. Those kind of advantageous methods arrays don't have, and we have to do the work ourselves. And so the only real disadvantage, or the one main advantage of an array, which also is considered a disadvantage, is the fact that we know the size ahead of time. So if you know you don't want to waste RAM, then an array would be a good choice. But if you're not sure how much input, how many things are going to be added to your collection, then an array list is a pretty flexible choice, and the one that most people would probably prefer. So we'll try some examples just to get comfortable using loops and array lists, just like we did with arrays. So I want to make a new class, and we'll call it something like array list practice. So we're going to have a main, and I'll leave it empty for now, and we'll implement some methods as we go. So the first method I want to do is, I think, pretty simple. I want a method that accepts a number, a single integer, and generates an array list with, two numbers, accepts two numbers. The first number is how many items we want, and then the second item is the largest number possible, inclusive. So for example, I might say 10, 100, and what I'm saying is create an array list that has 10 randomly chosen numbers from between 0 and 100, including the value 100. So this generates a random list of ints, and then it creates an array list with those values and then returns that as an input. So we can see the inputs will be typical primitive values and the output will be an array list. So we can see that array list is a data type. Therefore, our methods can return it as a value. It's a complex object and it has many sub-items inside of it, but still it is just simply an object. So let's try doing that. I would suggest you pause the video, try to make the signature yourself, come back and see if it matches mine, and then I'll tell you again to pause the video and try to implement it yourself, and then we can talk about a potential solution that I've come up with and see how close yours comes. There may be more than one way to do this, so it's good practice to try it on your own. So take a minute, pause, create the signature, and then we will implement the method afterward. And so hopefully you understood the idea. Let's go ahead and see what the signature looks like. We're accepting two numbers, the number of items we want, and then the maximum value inclusive. So we will say our access modifier is public. Our return type, and this is the part that's new, is an array list. And not just an array list of anything, but an array list of integer values. And remember, from last time, array lists in modern Java, we specify the type of data inside, and it cannot be primitive. So even though I want int values, I can't write int inside of my diamond notation. I must put the full wrapper class integer. And then we have to also import our array list class from the Java libraries once we're ready. So we're returning an array list. We'll call this one, I don't know, the name doesn't matter, but I'll call it generate random. We'll call it genRand list. And the input was the num items and then max value. And so there's the signature that we should have come up with. Of course, now I need to import array list. So I'll right click and do fix imports. It is java.util.arraylist. So it's in the same section as scanner because it was java.util.scanner. And so there's our method. And now we have to implement this. And again, if you don't remember, we're going to say generate a list of num items randomly selected from 0 to max value inclusive. Right, so we're saying between 0 and max value inclusive and randomly selected, and we need num items. So if that's 10, it's 10. If it's 20, 20 of 1,000, it's 1,000, and so on. So pause the video, try to implement this yourself for a minute, and then when you're ready, come back and we can see and compare your solution to my solution. Okay, so if you tried this, we can compare your solution to mine. So let's see. And the idea I think is pretty simple. The first and foremost, just like when we did arrays, is to construct the actual collection. We must have an ArrayList object in order to add things to it. Right? There is no container. Making a variable is not enough. We must call the new keyword with the constructor. And so ArrayLists are very easy to make, but we have to know the format. So our variable we'll say is of type ArrayList that contains integers. I'm going to call mine rands. The name is not important. And then now here's the construction, new ArrayList of integer. And again, I know that the compiler might allow you to do this, which is called the diamond operator, and you can, but I like to be explicit about what I'm containing just so it reminds me of what I have. And it is a constructor, and the default constructor accepts no parameters, so there are my empty parentheses, and there it is. So this is a constructor accepting, so this makes an empty list. So now I need to make and add num items and add them and between 0 and max value. So I think a for loop would be a good choice. So we can say for int I equal to 0, I less than num items, I plus plus. So if num items was 10, we're saying from 0 up to and not including 10. So 0 to 9, which is 10 items. If it's 100, it's between 0 and 99, which is 100 items. And then now we need to make a random number. So we'll say R is equal to a random number between, and I said inclusive, so between 0 and max value plus 1. Because if max value is 100, I want from 0 to 100, we know that we'd have to say, if random was 0, we'd get 0 times, well actually this is not correct, we have to do plus 1. In parentheses, because I don't want to forget the add one. I don't want to make the lower bound 1, I want to make the lower bound 0. So now we're saying, if it's 100, we're saying 101, 0 times 101 would be 0. And then if it was 0.9 repeating times 101, that would be 100.9 repeating. Or sorry, yeah, 100.9 repeating, and then truncated would be 100. So that's the range that we have, right? Otherwise, we would have between 0 and 99, we'd have between 1 and 100, which is not what we wanted. We want between 0 and 100. And so there's our random number, and then we have to add it to a list. And so the method we saw, and I didn't specify any particular order, so there's no worrying about ordering. So we're going to say just rands, the name of our list, .add. And we're going to add R. And again, remember, this version of the add method simply sticks to the end of the list, which is a very fast operation. Right? We know how many spots there are internally. Well, we don't know, but the ArrayList controls it and knows where to place the next item. If we try to put it at the beginning or somewhere in the middle, that could be very expensive, and we don't want to waste our efforts on that. If it's going to be random anyway, just let them get placed in as they're created at the very end. And then the last step, just like with most methods, is to return the object that we have created, in this case, rands. And there's our method. Now we could test this and print it. Let's go ahead and make a method right now to print an ArrayList. So I'll make this the signature, and you can implement the method. So we'll say public void print list. It takes an ArrayList of integer values, and we'll call it list. And now take a moment, pause the video, implement this to simply print out each number on a separate line. So we'll just see however many there are in this one line after the other. So if you've done that and implemented this print list method, it might look something like this. And I'm going to use an enhanced for loop because it's simple. I don't care about the indices, I only care about the value. So for every int n in the list of numbers. And again, remember, the term for this automatic conversion between integer and int is called auto boxing. Auto boxing goes from int to integer and integer to int without having to do any work ourselves. That between the wrapper and the primitive value. And I can simply print out n, whatever value it happens to be. And if we look at this warning, this is a more modern thing for Java. We're not going to touch that functional operation, but this is a pretty easy thing to do. So now let's go ahead and in our main test the two methods. First, we'll generate a list. So of course, if this returns an array list, I must make a variable of type ArrayList, right? Because that's what I'm containing, and we'll call this randoms. and we will call the method gen rand list. And I'm going to say, give me 10 items where the maximum value is 100. So if we look at what I made a mistake. Oh, of course we are in main, so we do have to make this a static method. That's my mistake. And there it is. The same thing will apply here. And so that creates the list. Then we can simply call our print method, so print list on randoms. And let's see what it looks like. Give it a moment to compile, and we should see a result that shows at least 10 random numbers. So there they are, 10 random numbers. We'll run it again. Hopefully we won't see the same batch. And there we are, 24, 66, 76. Let's run it one more time. And there it is, right? So 10 random numbers. And of course now if I bump this up, 100 numbers between 100 and the ranges are between 0 and 100, then now there are a lot more numbers. And there they are. There are 100 different integer values. And there was 100 2 times it showed up as different possible ranges. Now I didn't see 0 anywhere, but it's possible that 0 is a valid number. So far so good. Again, we can return ArrayLists just like any other primitive or non-primitive data type. That's the takeaway from this first implementation. ArrayLists are objects and therefore can be returned as parameters. And then our print method shows ArrayLists are objects and therefore can be inputs to methods. And so that's a good use for these. Now, let's go ahead and try something like, and I'll write the definition. I want to say create a method that accepts an array list of integers and a single integer value and returns the percentage of values of numbers above the given value. So for example, we might say here's the list of 100 values and the number 22, and we're saying what is the percentage of values, integers, over the number 22, right? And we'll say strictly above, so say strictly. So if 22 would not be included, right? Or we can say instead of above, we'll say greater than. And so that's our implementation that we're aiming for. So do yourself a favor, pause the video and try to implement it all. Write the signature, write the implementation, and then maybe test it, and we'll come back and do it together again with my solution, and maybe yours will be similar, and hopefully work successfully. So I hope you tried it out. It's not too complicated, but it does require us to do a little bit of thinking and make sure that we can keep track of values in the summation that we've done with arrays before. So for our signature, let's say it's public, we want someone to use it, static. The return type is a percentage, so a double would be a good choice, because like 0.79, and I didn't really say it, but we could say like 0.79 is 79%, so a decimal value. And so maybe I should add that to my definition. Percentage, decimal numbers, right? So our return type is a double, and we'll call it percent above, and we'll accept an array list of numbers, of integer values. I'll call it list, and then a single num, and we're saying how many or what percentage of the values inside the list are strictly above or greater than that num value. So we'll say int count, right, because we are basically keeping track of how many there are, and if we divide it by how many there are in total, then we have the average or percentage of values above it. Not average, but the percentage above it. So let's go ahead and do that. So let's say, and again, I don't care about the indices so much, so an enhanced for loop, in my opinion, is a great way to write this. We can say for every number, and I call it n, because again, the name is not important, in the list, for every number in the list that's of type integer, if the n is greater than, and strictly greater than the number that was given to us, then our count increases. And that's it. And then finally we can return however many there were, divided by the size of the list. Now there is a danger here, so we should probably check, and sorry, not n, but count. And what is that danger? Consider they give us an array list, an empty list is a valid list. And so if the size is 0, we would divide by 0 and get an exception or not a number value. So we wanted to check that. So let's do that first. Let's say we'll ask outright if list.size is equal to 0, then we'll just return 0. Otherwise, we return the number of items over the total size, which is the percentage of this. Right, so let's take a look and test this method and see how it goes. In fact, if you wanted to, we could do this if statement first, because there's no need to even do summation. I mean, this loop would run 0 times, so it's kind of arbitrary, but we could do this technically first to save ourselves the little bit of extra work that we may have done, but in reality, there's no difference. Right. Okay, so let's go ahead and try doing that. Let's test this method. And so we have our random numbers. Those are the 100 numbers that we've generated. And now let's say int percent is equal to, and our method is called percent above. We'll say percent above. And the list we're giving it is randoms, and the number, let's go over 50. So how many, and if this is randomly distributed, then we would hopefully expect something close to 50%. About half of them should be above if it's an even spread. And with a small set of numbers, maybe it won't be obvious, but the bigger the set, the more likely it should, if the implementation is uniform, it should tend to about 50%. I'm sorry, this should be a double because it is a percentage, not an int. And there we go. And then let's print it out. Oops. There it is. And we'll say, yeah, percent. And we will attach our percent. So let's test it out. And now I'm not going to print the list anymore just because I don't want to waste time. Actually, no, I should just to see it. Not a bad idea. So let's run it. So there they are. Oops, I did something wrong. I definitely did something wrong. So there's a bunch of numbers, and you're telling me that none of them, the percentage over the number 50, unless, I mean, it's really unlikely. And that's already proven false. 68 is above 50, 56 and 80. Therefore, we should have gotten something greater than 0. So what did we do wrong here? What did I do wrong here? So we said for every value, if you're greater than num, then add to the count. So that should be a non-zero value. If the size of the list is 0, return 0. Otherwise, return the count divided by the size. Now this is an integer and this is an integer. And so we should maybe make sure that one of these is a double before the math occurs. That's probably what went wrong. And of course, that's in fact what went wrong, because unless every single one was above 50, then this would be some fractional number below 0, I mean below 1, and therefore round to 0. So let's force it. Now I could have made count double, but I prefer to do the conversion, just because I think when you count things, you should count them as whole numbers. So let's try it again and get a better answer. And there it is, 53%. That's not bad. Let's run it again. 48%. Okay, that's pretty good. 46%. Now again, let's amp up the number. So 1,000. I claim that the more we do, the more likely it is to get closer to almost 50%. That's only, each of those is half a percentage point off, which is pretty good. It's about almost a 70, 48. So that's a little bit far. We can see that it's getting close. And of course, I'm going to do one more. I'm going to do 10,000 numbers. And I believe that our fraction will get closer and closer to exactly 50%. Again, there will be variation. It is random, but it is uniformly distributed, so we're getting closer to 50% every time. Good. So it seems like it's working. Again, the takeaway, we can accept array lists as inputs. We can generate any output. There's no limitation. And again, we should just be comfortable with the idea of looping through. And so far, we haven't needed to use the indices anywhere, so enhanced for loops are pretty fantastic for this. They really do make it easy to get content and not worry about indices and where things are. Maybe we need to do that, but for now, we really don't. So let's try another one. Let's try something like creating a method. So create a method that accepts an array list of strings and returns if all alpha, I'll say all characters in the alphabet, there are 26 of them, appear across all the strings. Right, so if I have an array list of a bunch of different strings, I'm saying does every letter A to Z appear at least once in any of the strings? So the total is, as long as across all the strings I see every one of the 26 English alphabet letters, then I return true. Otherwise, I return false. Right? returns if all characters in the alphabet appear across and false otherwise. Yeah, okay. So now, again, pause the video and try doing that. And if you want to go forward for a moment to see the signature when you're ready, then you can do that. But I think this is a good practice of using non-primitive values. Even though integers are not primitives, they are wrapper class objects, we've been dealing with ints. Let's try some string work. It's a little bit more effort. And this solution, I think, would be more varied across different people's potential with the kind of answers we may come up with. Okay, so hopefully you tried this out. I know this one is a little more challenging, but let's see how we do. And maybe my solution is one that you came up with. So our signature, public and static, we want to be able to use it here temporarily. The return type is Boolean because it's a yes or no answer. Yes, every character was found, or no, it was not. And I'm going to call this one has alphabet. The name is not important. And the input is an array list of string objects. Again, that diamond notation is basically for the objects that are inside of our list. I'm going to call it list. So if you haven't done it yet, pause the video, try implementing this method and see how it goes. Otherwise, we're going to try that in a moment. So if you've done this, great. If not, we can take a look together. And so the idea is that I need to know that every character has been seen. And now, there's a lot of ways to do this. I think that maybe the easiest approach is to, let's create a string, and we'll call it alphabet. Let's make it contain every single letter. A, B, C, D, E, F, G. So there's my alphabet, all lowercase. And I'm going to assume lowercase. It doesn't really matter. I could do two lower, and I will make sure it works for any words, capital or lowercase. But there's my lowercase alphabet. Now what I think my plan is, let's go through each character in this string, and then look through every string and say, does it contain this letter? And then if it does, then we move on to the next one. If at any point it fails to contain the letter that I'm currently looking at in this string, then that means not every character was found. So if I happen to be looking for G's and every string that's in the array list does not contain a G, there's no point in looking at the next one, because if there's no G, then therefore not all alphabetical letters have been found, and the answer is false immediately. We're looking for it's a proof by contradiction. As soon as you find a failure, you know the answer immediately. There's no need to argue with it, and so that's what we're going to do. So here we need a loop to repeat through every character. So for int I equals 0, I less than alphabet dot length the method, because it is a string. And now we're going to say, okay, well, let me get the character. So we'll say string letter is equal to, we'll say alphabet dot substring I to I plus 1. So that gives me whatever character I happen to be at. So now I have the letter, so A, B, and so on, and now I need to look through every string and say, have I found it? So let's ask the question. So we'll say, if, well, I need to go through every string in the array list, so we're going to do another for loop. This is a nested loop. Again, I think an enhanced for loop is the best choice here. So I'm going to say for every string str in our list, let's do some work. And our work is now, let's say, how do I know if a string contains a character? I could loop through every character in this one and then compare it against the one I'm looking for. Or I can hopefully use, and the reality is this is how it's going to work, we use the index of method. The index of method is a very helpful method. Remember, it says, you give me a substring to look for, I return the index where I find it, and if I don't find it, I return -1. So essentially, if I index of for letter and I get a -1 back, that letter must not have been in the string. And if at any point I fail to find that thing, if I don't have any, then that's a problem. Right? So let's do this. So we're going to say, we're going to have to make some setup. We're going to say Boolean found. So we're going to assume the worst case, that we have not found it. And hopefully, as we loop through these strings in the list, we will find it in one of them, and then we can turn this to true, and therefore our loop will not end. Right? So let's try this. Here we go. We're going to say if the str index of the letter we're looking for is not equal to a -1, so we found it somewhere. We don't care where. We don't care if there's duplicates. We just care that we found it. Then we return. In fact, we don't have to even do an if statement. We can assign it directly. Let's say, you know what? Did we find it? We'll say found is equal to Actually, no, we do need to do an if statement because we want to guarantee that we don't accidentally end early. And so let's do this. We're going to say if we found it. Okay, here we go. So if we did not, if it's not a -1, we did find it. And we will say found is true. Because if we happen to find when it's not, we don't want to set it to false. We want it, once it's true, we want to leave it true. So if the index of did not, and again, notice it's really smart. There is a method that does this for us, but I'm not using it on purpose. I want us to use the AP exam approved methods. Index of is that method. So if it wasn't a -1, then we must have found that character in one of these strings, and we don't care which one, and that's it. Now, if we manage to get through all of them, and we did not find it, then we know that it doesn't matter if I go to the next letter, this letter was a failure. We did not find a match, therefore not all characters were found. So if it's not found, we can return false. It failed, we did not find every letter in the alphabet. Right? And now let's go ahead and do our last thing, which is a return of true. If we manage to sneak through every character and every string and find a match every time, then it must be true that we looked at every letter in the alphabet. So there's our final result. Now let's test this. This may be a little bit hard to test. I think there's that famous sentence, we can put one string. I believe it's the quick brown fox jumped over the lazy dog. I think that's it, but maybe I'm wrong. Let's do this. So let's try this out. Let's say we have to make an array list of strings. So I'm going to call it words. Or strings. We'll call it strings. And we'll say it's a new array list of strings. Let's add at least one string. So I'm going to say strings.add. And I'm going to put that one string. Oh, here's what I missed. I wanted to do capitals or lowercases. So we should say the lowercase version of str. So let's do str.toLowercase. .index of. So we're saying, hey, look at only for it in the lowercase version. That's, I think, a more important distinction. So the quick brown fox jumped over the lazy dog. If that's a sentence, then I think I'm in good shape. If it's not, then we'll know because it'll return false. So let's see if it does it. So let's print out, and we called it, what is it? What did I call it? I already forget. We called it has alphabet. So has alphabet, and we pass in strings. So this is an array with one item, and then if this item has all 26 characters, then we're in good shape, and it returns true, otherwise it'll return false. It's false. So either I did the sentence wrong, or my code is incorrect. So let's verify this. Let's do a little bit better. I mean, we can check for every letter. A, B, C, D, E, F, G. Let's look for H. Yep, H, and then I. There it is, and then K, or J. I'm sorry, J, and then K, and then L, and then M, and then N. We're looking for N is in brown. O is in fox. P is in jumped. Q. R, S. Did we see an S? The quick brown fox jumped over the lazy. I think S is the one that's missing. So maybe I did something wrong in missing that. So let's jump over lazy dogs. And then how about T? There's T in the, and then U is in there, and then V is over, and W. And then X is in fox, and then Y is in that, and then Z. So let's see. Now let's see. There it is, true. So what was an S? So I don't actually know what the original sentence is, but clearly I was missing an S. But now that we added the S, it found all of them. There's every character. And now let's do this a little bit better. Let's do this. So we'll put the, and then we'll put the next one. We'll say strings.add. And then we'll do the next one. And the next one. Right. Just to show that it is across multiple things, and I'll do one more. That's good enough. It doesn't gotta be perfect. So there it is. It's across multiple strings, and we should still get true as an answer. Otherwise, there's a problem. And there it is. It's true. And then let's go and get rid of that S. And run it again, and we should get false. And there it is, right? So the idea is that we can look through an array list. We can look through, and again, nested loops, while they can be challenging, really do allow us to do a lot of different things. So I'm going to stop here, and I hope you've seen some examples that really make sense to you in terms of the usage. And again, whether you use an enhanced for loop or a while loop or another for loop, it's perfectly fine. I use enhanced for loops mainly because there's no need to use the index, so it doesn't hurt to do it this way. So I'll see you in the next video. We will continue more with ArrayLists. They are a very powerful tool, and really they are kind of a giant replacer for arrays, even though on the AP exam we must be comfortable with both and iterating over them both and so on. So I'll see you in the next video.